The graph below has a circle centered on the origin, and we have a ray that goes through here, 12, 16. And we've seen this similar before. It's what we've been doing, but now we're trying to find the value of cosine. Okay, so we're switching from sine to cosine. And cosine is adjacent over hypotenuse. So same process, we need to start by finding the radius length, or it's also the hypotenuse. So we're going to use the Pythagorean theorem again and label our sides. We're going over 12 up 16. So if we're solving with Pythagorean theorem, our side lengths that make up that right angle are the A and B. Across from the right angle is the hypotenuse. So 12 squared plus 16 squared equals C squared. It's 400. And then to get rid of the square, we take the square root of both sides. So we want square root of 400, which is 20. So C equals 20. Now we need to figure out which side is the adjacent side. Well, the one across is the opposite, and the remaining side next to it is the adjacent. So it's 12 over 20. Those both divide by 4. So 3/5. And then in this particular one, W and theta are the same because we're in the first quadrant. So I'm going to take cosine of W, that's our inner angle on our triangle, which we just found out was 3/5. So now to solve for W, you take inverse cosine of both sides. These cancel out and it leaves W by itself. So W is inverse cosine of 3/5. So in your calculator, make sure you're in degrees, and then all the trig functions are here. So inverse cosine of 3/5 would be 53.1 degrees. And these happen to be the same because we're in the first quadrant.